Afternoon, Domo. You can let me know if you can hear me, please and thanks.
Good afternoon, sir. Yes, I can hear you. You
Yeah,
can hear me, sir?
okay. Yeah, man, I can hear you. Thanks. I guess we can wait a few minutes, see if there's anybody else that's going to be joining.
Yes, sir.
Mhm. Question for you in the meantime. In terms of other classes, um, I imagine that you're classmates with other people that you expect to be here today, right? Or you
Yes,
don't know
sir.
anybody? Okay. You have an idea of how many people going to be in this class? I don't have eyes on the students' numbers yet.
Uh, could range between, I think, 25 or 30, or
In,
probably a bit less.
in this class?
Yes, sir.
Oh, really? Oh, it's very different from what I was told, but I guess we'll see.
It's probably not that much, but sometimes sometimes more students will be here, sometimes not a lot, since some
Mhm.
people are working.
Understand.
So not
Yeah.
everybody will be on online at the time.
Mhm. Yeah, Canvas not showing me the student list yet. But I guess that will change eventually. Mm, Evening, Tyreek. Sorry, I just joined. I'm just waiting for other people to join. Probably just wait maybe a couple more minutes.
Evening, sir.
Evening. If you share my screen, you can tell me if you can see it.
You sure now, sir?
No, not sharing yet. Hold on one sec.
Oh,
Yeah, sharing now.
I can see it now.
Yeah, cool. All right. Um, you guys okay with me just continuing or just starting now? This is just us three,
You can
even though it's just
continue, sir.
All right, cool. And I guess the recording will be there for whoever wants to check it out after. All right. So evening, gentlemen. I'm Philip Logan, and we're going to be going through a little bit less than 2 hours of, I guess, the introduction to this course, systems integration. Um, so this is going to be my first time actually teaching this course. And I guess what that would mean is I'm still kind of getting used to the content. Um, the topic itself, systems integration, is not new to me, but I guess teaching it in this formal sense is a bit new to me. So I guess that means hopefully I'll be learning just as much as you guys along the way. Yeah. It being a theory course, you're going to find that a lot of the activities that we have going come in the form of discussions. Let me see what the chat said. Oh, I did not realize it's purely BDIT course. There's only going to be three of us. When you said three of us, you mean the Muay Thai and Philip? Or is there going to be one
And
more?
one more person, sir.
Yes,
Oh,
sir.
Somebody by the name of Romain Higgins.
okay. All right. Well, not wrong.
Well,
Um, do you know if Romain is on way?
Don't really know, sir, but he's usually at work at this time.
Oh, okay.
Usually
All right, no problem.
comes in late.
All right, no problem. All right, that's fine. Can you see this window on my screen, the chat window? Or
yes,
is it only
sir.
me can see? Oh, you can see it. Okay, no matter. All right, cool. Yeah. Yeah, so I guess it will only be the four of us for this semester. Um, I guess a few things that we have to go over for housekeeping reasons. Let me see one sec. I have my notes on the side I'm reading from. So if you hear me pause, it's because I'm looking at my notes. Give me a sec. Mhm. Right. So we're going to start off in Unit 1. I don't remember if I posted the course outline. If I didn't, I'll try to post it as soon as I get time after class. But yeah, the course outline should be on Canvas for you guys to view at your own leisure. You all have access to this course on Canvas at the moment. So if I post something, you'll see it. Can you confirm for me, please?
Not as yet, sir.
Oh, okay. All right. Got you. Hopefully we can get that sorted out soon. So yeah, what we're going to be talking about in tonight's session, um, we're going to be focusing on understanding what systems integration is. We're going to be exploring the four main types of systems integration. Um, that's what we're going to be covering mostly in Unit 1, which is an 8-hour unit. Today's Tuesday. We meet Tuesdays 6 to 8, and I think is what, Thursdays 6 to 8 as well. So that's going to be 4 hours of class a week. And this first unit is going to be 8 hours. So it should take us 2 weeks to get through it, more or less. And the number of contact hours that we have in the class is 45 hours. So it's seemingly a short course. You guys saw notice that this semester, given what happened last semester, is going to be an abbreviated semester. So I imagine that means we're going to have less time to get through all the content than expected. Not sure if you'd have seen that notice. You can confirm if you saw that notice.
Yes, sir, I saw it.
All right, cool. All right. So before I continue, any questions so far? Did I say that my name is Philip Logan? I'm not sure if I said it, but you probably see it in Zoom. Any questions so far?
None for now, sir.
All right, no problem. All right, let me ask you a question. What comes to mind when I say systems integration? Can I get an answer from both of you since it's just the two of you? It's going to be hard for you guys to hide from me.
Kind of remind me of ERP,
ERP. Tell me what you mean by ERP.
enterprise relation. Repeat me that again. That might you remember. You're supposed to remember this, but ERP is basically implementing systems into businesses for certain
Mm.
stuff like accounting and so.
Oh, okay. Okay. Yeah, you're on the right track. The more you
Yeah, I
want
was
to,
think
yeah, go
yeah, I
ahead.
was thinking the same as ARP, but in
Mhm.
terms of I think this would be more general than ERP being specific for like a business. So I'm thinking
Mhm.
the system integration would involve like as much as it still be about business, it would be like integrating the system into other things otherwise from the business.
Right.
Like uh I'm not sure if it would be a good example, but like if a system, if like a computer system or something
Mhm.
needs something otherwise from human effort to
Mhm.
be integrated into the system.
Mhm.
So instead of having the human being doing it, it would
Mhm.
be the implementation of the system to replace like the human error in certain things.
Okay. All right, I hear what you're saying. Um, so the both of you gave pretty good definitions or pretty good understandings of the content. You were more on the right track when you were both talking about, the business aspect and the business relationship. It's not to say that we're going to be covering business related topics that might be involved. It will be involved, yes, but it won't be the main focus. You made a good point moving over to computer systems, or yeah, I guess you said computer systems. Um, One of the key factors that we're going to be looking at, yes, is computer systems, but it's not necessarily going to be focusing on what separates it from the human effort or the human interaction. What we're going to be looking at mostly is how these different systems, and when I say systems, it can mean anything. It can be any entity, as long as we have some kind of input, output, and some processing, right? We're going to be looking at how these entities can work together to accomplish a common goal. So a system can be, let's all right, actually no, let me not get ahead of myself. When I get to it, I'll get to it. All right. I'll give you a better explanation when we get to that slide. So yeah. So what is systems integration? So we'll start with a core definition. Um, so one sec. We're gonna start with our core definition. We're going to be looking at the four different approaches organizations use to connect their systems. And like I said, not just organizations, but different kinds of systems. We're going to be comparing them side by side, the different kinds of systems integration. And then I guess I want to hear from you. So I'd asked you a question a while ago. After we go through the content, we can talk again and we can see how the information that I gave you, see if it made any more sense, or we can, have a discussion after that. Discussion isn't going to be any kind of test or anything like that. It's just to get your understanding. And also to fill time because it's going to be a lot of content. Because like I said, it's a purely theory course, so it's a whole lot of talking. And most of the activity is going to come in the form of discussions, or at least the in-class activities when come in the form of discussions. Yeah. All right, so let me see now. So what is systems integration? So the process of connecting different computing systems and software applications to function as a unified system, right? The main goal of this, we're trying to establish three common pillars or three very important pillars. We're trying to connect. What I mean by connect is we're trying to physically or logically link our systems that were built independently. When I say independently, what I mean is these different entities could be created by different vendors or different manufacturers. They might be built using different technologies, and they might be built at entirely different times or time periods. And next thing that we're trying to achieve is communication. We're trying to enable data to flow between these systems. It's not enough to just put on a cable and expect them to just work. The systems need to be able to understand each other's data. Remember earlier I talked about a system having some kind of input and an output and some processing being done. You're going to find that in these interconnected systems, the output of one system may serve as the input of another system. Yeah. And then the third thing that we're trying to achieve is coordination. So we want to make the system work together. The interconnected systems work together as one cohesive whole. When one system acts, the others respond appropriately. I can pause here. Tell me if I lost anybody. Let me know if I'm making sense.
Understanding so far, sir.
All right, cool. And if anything, if there's any issue with what I'm saying, if my audio cuts out, I'm not sure if my audio can cut out. It shouldn't. But if I'm getting too fast, you can let me know. If there's anything you want me to repeat, you can let me know. All right. So I had mentioned, all right, you had given an example to say when you think of business integration, system integration, you think about businesses. And I'd given an example to say that systems integration it involves organizations. But it's not just organizations, not just businesses. Let me give an example of how we can apply outside. Think of your phone, right? Your phone, it connects to Wi-Fi. You might have Bluetooth earphones or speakers. If you have an iPhone, you have iCloud. If you have Android, you have Google Drive. And then you have your Gmail or your student email, right? All of those different aspects of your phone, all those different features that your phone can carry out, they're not all made by the same person. It might be a case where if you have an iPhone, maybe all those different features are built by Apple, sure. But you have other apps on your phone. And those apps that are on your phone, they're not made by Apple, not all of them at least. And they're not going to be made by Google, not all of them, right? But they all work on your device. And it might be a case where you have information in one app that is able to be transferred out of that app and imported into a different app, right? From your perspective, yes, all these different components are made by different companies, different vendors, different manufacturers. But from your perspective, everything just works as your phone, right? You didn't have to do any kind of translation or difficult configuration to get information from one system on your phone to work well with a different system on your phone, right? If it is a case where you have, well, okay, actually, maybe this might be a good example. I was going to make the example to say that, like, say, for instance, you wanted to share a reel on Instagram into WhatsApp. The reason why that's not really a good example is because Meta owns both of those apps. So they would be doing their job to make sure that those two separate systems are able to communicate with ease, seamless ease, right? Tell me if I'm making sense. By the way, let me get the idea. I am assuming that I'm talking to people that use Instagram, social media. So I want to know if my
Yes,
example
sir.
makes sense.
Yes, sir.
Okay, yeah. All right, making sure. Yeah. So I'm asking that question because I'd like to know how to structure the examples I give if it's a case where I need to give an analogy or something like that. Right? Okay. So let me see now. Right. So with the different systems that you have on your phone or different apps that you have on your phone, you don't have to do anything special to get information out of one app into a different app. Everything just works. It doesn't really matter what brand your Bluetooth speakers are or your Bluetooth headphones are. We go through the same setup. You pair the device to your phone in the same way, and the manufacturers make sure that these systems work right across the board, across all different devices, so that we can get a smooth user experience. So that's what I mean when I talk about systems integration. Systems integration applies to stuff like this, not just this. So we're not just going to be talking about hardware devices. We're going to be talking about hardware, software, businesses, organizations, and all that other stuff. All good? Let me know if we're good, please. I think you should also be able to, if you don't want to unmute, you can just thumbs up. If you can find that button in Zoom, you can let me know.
Yes, sir.
All right, cool. So yes, 1 second, let me put through my notes. Okay, so we see these different boxes on the screen, right? Student registration, finance and billing, learning management, library system, and HR systems, right? Can I ask, in terms of registration, you guys have been at the college for a little while, I imagine, at this point.
Yes,
Actually,
sir.
how can I get an idea of how long you guys have been here? You guys are like, what year of study are you guys?
We're fourth year, sir.
Okay, so yeah, man. So you've been through the system for a good while. And given you've been in the system for a while, I would imagine that you'd have gone through your fair share of issues in trying to get like administrative matters or, just logistical matters, stuff outside of studying and academia, like stuff in terms of, I don't know, registration, paying your tuition, things like that. Can you give me an
Yes,
example
Yes,
of some of
sir.
the issues that
Yes,
you'd
sir.
have faced? Yeah, man. Okay, so good. So give me an example of some of the issues that you'd have faced. Like you don't want to give too much personal information if you don't want to. But I just want to see if I can relate it back to the topics that we're going to be covering. Don't mind,
What
since you
I
said
say,
this. Oh yeah, go ahead. Don't want to start talk same time and don't want to stop.
okay.
Mhm.
One major issue is the system not reflecting that's been put in it. How can I say this? The example was, at exam time, in order to get an exam permit, you have to be fully paid off your school fee, and so
Mhm.
I've done that, and they entered into the system that I paid off everything, but when it came around to exam time, when I was supposed to go into the system and get the exam permit, the
Mhm.
system wasn't showing that I had outstanding payments,
Mm.
even though they
Okay.
had logged it into the system.
Mhm. Okay, I get what you're saying. So you had gone to one particular entity on school and they asked you a bag of questions and you gave them the information and they stored it
Hmm.
somewhere, right?
Yeah,
And then now you were expecting to go somewhere else and for them at the other place to see this information reflected so that you could get what you wanted to get, right?
yeah,
All right. The issue that you were having was that when you went to the first place, you weren't able to confirm that every other system that was connected was made aware of that new information or that update to that information. So it sounds like in that case, there was an example of either no integration or poor integration, right? So let's look at without integration. So staff manually re-enter student data across 5 systems. In your case, it might have been a thing where the first department that you had gone to, they took your information, and then maybe with the next, what you said it was an exam pass, I think you said you had to go to.
yes, sir. The
You had to
exam
get, yeah.
pass.
The people that are in charge of issuing the exam pass, maybe they had to call the other department and check to see with them manually if it was a case where, you did in fact go to them or something of the sort instead of it being an automatic update of information on their system, right? So because of the lack of integration, it would make things a little bit different. It make things a little bit slower, right? Um, it could even cause errors because if it is not a case where information is updated in one place and then shared across other places, you could have a case where You could go to one entity or one department and then take your information. And then when you go to another department, they take your information again because they don't know about the information that you had given in the first place. So that could lead to duplicates, and duplicates could lead to errors. Yeah.
Yes, sir.
It
Because
could even
how
that.
to
Go ahead.
how I fixed the problem, I had to go back to finance and they had to re-enter me into the system so that I paid it
Re-enter you.
enough.
Really?
Yeah.
Okay. I see. That's very interesting. So it's potentially the first time you got the information shared with them, maybe it wasn't stored. Well, whatever the issue was, definitely an internal issue that hopefully doesn't happen ever again. But yeah, so the example you gave where one system isn't reflecting the information on another system, or you may have to give information twice. This can cause a lot of different problems. It could cause duplicates. It could cause hours wasted. But let's take a look at if we did have proper integration. You are trying to accomplish some goal, so it requires that you register. An example would be like you register for a course, right? You register online for your courses, and your data is supposed to automatically flow to billing, right? And when I say billing, this is just hypothetical. I'm following the boxes that I have on screen. So you register for a course, or not register for a course, or a program, whether it be full-time or part-time. Depending on whether you choose full-time or part-time, the billing system at ECC is supposed to trigger some event to say that, this student, since they chose part-time, they're supposed to be charged this amount of money. And with this amount of money being charged to you, it would allow you this, and that privileges or accessibility on the online courses. Sorry, not the online courses, the online systems like your Canvas. And what other online systems do you guys have access to? I have access to Arian. Do you guys have access to Arian? You see grades on Arian? Or is that just me?
No, sir, we
Yes,
can
sir.
see
We
our
see
grades.
this see the
Come
grades
again?
and do the registration on area.
Okay, so you see that on Arian as well. Yeah. So you would have registered for your program, and billing would have gotten an event triggered on their side to say that John Brown registered for the course and they're supposed to be charged this much money before they can see the content on Canvas. And then now the next step would be John Brown paying the money at the billing department. And when they record that John Brown has paid off all the money, or if it's a case where it's supposed to be a payment plan, if they're able to verify that they are in good standing on their payment plan, it's supposed to then trigger another event in the learning management system to say, all right, this person is in good standing with them account. You can give them access to the content on Canvas that they're supposed to see for their courses, right? This stuff not supposed to be done manually. This stuff supposed to be integrated so that all the different independent systems are able to communicate with each other without anybody having to go in and manually trigger or enter any information. Am I clear? This is good? Awesome.
Yes, sir.
All right. So let me see. One sec. Oh, I have an example here. It's kind of a optimistic hypothetical. Imagine you guys ever go tax office? You ever had reason to go tax office?
I went
You
to
guys,
tax office, but not for myself, sir.
okay,
It's
understand.
someone.
Well, regardless of whether it's tax office, you go somewhere, you go for yourself or you go with somebody else, you may be exposed to all the different documentation that you would need anytime you need to do anything government related. You need your TRN, you need your NIS, you need your birth certificate, you need three passport size picture stamped by JPs and all them something, right? And it doesn't matter how many times you go to these government bodies or how many times you go to the tax office, you always have to carry that information. You'd imagine that because they're all under the government, they should hopefully store this information if you're allowed them to store this information. Anytime you need it, them just pull it up and just reference it back to maybe an ID number or something like that. But that isn't the case. That isn't the case because I guess the infrastructure here in Jamaica, at least as far as I know, isn't at the level of system integration that we'd want it to be to make it into a flowing, coherent, seamless system. Yeah. So with that, we're going to need to, in order to try to implement the different kinds of systems or take a look at the systems and criticize them as to how they're operating, we first need to get an understanding of the different types of system integration. Right? So, one sec. We have different types of systems integration, right? What slide am I on? I'm on slide 5. Sorry. So we have vertical, right? The hierarchical stacking of subsystems by function. I have the star or the spaghetti system integration type, where we have point-to-point connections between each and every system. We have horizontal, which is the central middleware layer that connects all systems, and then you have the common data format, standardizes data exchange across all systems. All right. So with the 4 main approaches of system integration, each one has its own philosophy. Each one has its own strengths and its own trade-offs. And we're going to be looking at each one of those things in detail. All right. So let's see. Let's start off with vertical. All right. So simply put, we're looking at the diagram on the right, where we have system A feeding down into system B, into C, and then D, right? We see a chain. Each system only talks to the one directly above or below it. So we could think of this. What is a good example of this? A good example of this could be like a small shop, maybe a small supermarket or something like that, right? We have a point of sale system. That would be like the system that the cash registers are connected to. And that might feed into the inventory system. So every time a shopper comes up with their stuff, the cashier scans the products for billing, and then as soon as the payment is confirmed, the number of items, the particular items that you get, might be deducted from the inventory, right? And then now that inventory system might feed information into a supplier ordering system. What I mean by supplier ordering system, maybe it's a case where your supermarket, it has a limited inventory and they know exactly how much, I don't know, Pepsi they need to have in a month. So if they have 40 bottles of Pepsi and somebody come and buy 30, then automatically maybe at a particular time of the month, it will trigger an event in the supplier ordering system that say, we only have 10 bottles of Pepsi left. We're supposed to have 40, buy 30 more. Yeah. So that would be an example of, one system leading into another, where we have system A talking to system B, then to C, then to D. In this case, we refer to that as a tight coupling. The reason we call it a tight coupling is because, let's say, for example, if system B, in this case, this hypothetical system, if system B changes how it formats the data, then we'll have a problem. Both A and C are going to be affected. It's going to be difficult for you to change how one layer works without potentially breaking other layers. Before I move on, can you tell me if you get what I'm saying with the example I gave a while ago? I was looking at system B and I was saying, if it is a case where system B changes the way it either inputs data or outputs data, it could affect either system A or system C. Tell me if you understand what I'm saying.
Yes, sir.
Right. So one of the things I want to emphasize, as I said a while ago, tight coupling. The tight coupling comes as a result of, the way a particular system works is going to be dependent on a system either above or below it. Tight coupling versus loose coupling, a concept that will eventually going to come up. It's going to come up a few times throughout the course, to be honest. But tight coupling means a system is heavily dependent, or systems are heavily dependent on each other. So a change to one would ripple throughout the rest of the systems. Yeah. And we're going to be talking about the This would be considered one of the trade-offs of a system, depending on which system you're looking at. All right. So one sec. All right. Questions on this particular type of system? Or we're good? Move to the next one.
Good, sir.
All right. So this one, the star or the spaghetti integration. Okay. For this one, I want to see if I can give a quick example. Give me one sec. Give me one moment. All right. So let's say, for instance, I have a room, and the room is hosting an event. And we're supposed to be doing some networking in this event. When I say networking, I just mean like, interpersonal networking. So I stand up in the room. Wait, hold on. I stand up in the room, me by myself, yeah? Another person comes in over here, and me being the social person that I am, I want to shake their hand, right? So a handshake occurs between me and this other person. If it's just me and one other person in the room, can you tell me how many handshakes occur? If it's just me and one other person?
One.
When I say handshakes, yeah,
That's
okay.
one,
So
sir.
just one handshake, because after I shake them hand one time, I don't need to do it again, right? All right. One other person enters the room. Another person here, so I'm going to draw a line here and another line here. Well, hold on. Another line there. Okay. Can you tell me now, with 3 people in the room, how many handshakes are going to occur?
It's a 3, sir.
Three, sir. Three handshakes, because we're gonna have one handshake here. So this is going to be person A shaking hands with person B shaking hands with person C, and person A shaking hands with person C as well, right? So it's going to be 3 handshakes. If it's another one right here, so we have a handshake here, a handshake here, and a handshake here. How many handshakes we have now? We can just count the lines. So 1, 2, 3, 4. Is that 5? 1, 2. Yeah, okay, 5. No, 6. Is that 6 handshakes?
Yes, sir. 6.
So one of the things I want you to take note of, the number of connections in between each entity. I would have referred to them as people, but one thing that I want you to take note of, hold on, let me change this, change that. Where we have a circle, I'm going to call that a node or an entity. And in the line that goes from one node to another is a connection. With the number of connections that we have, the number of nodes that we have, the amount of connections will go up in an exponential manner. So right now, we only have 4 nodes, and we have 6 connections. It's a relatively close number. But let's say, for instance, we had 10 nodes. Can you guess and tell me how many connections we'd have between the 10 nodes? Let me see, can I draw that? While I draw it, you can see if you can do some maths and tell me, or maybe draw it yourself. So this is 1, 2, 3, 4, 5, 6, 7, 8. I don't have enough space. All right, 9 and 10. Can you tell me how many connections I would need to draw to make it so that each node is connected to each other node? If you want to try to take an educated guess, you can do that too. Let me hear your thoughts. What are you thinking? How many nodes you think, or connections you think we're going to have? Any ideas? All right, what if I gave you this formula? I have a formula here. I think it's something along the lines of what? N times n minus 1 over 2, where n is the number of nodes. Yeah. So in this case, we'll have 10 nodes. So n is going to be 10. You can plug 10 into this formula and give me a number and tell me how many connections this formula will give us. By the way, it's fair of me to assume that we're technical people, right? You guys are doing a bachelor's in IT, so we'll have the maths knowledge.
45, sir.
45. Okay. Does that
Yeah,
sound like a lot? Come
yeah.
again? Sounds like a lot, eh? Just for 10 people in a room, we're going to have 45 different handshakes. Try it with
So, so what's the formula again? What does this represent?
this
And
That
formula represents the number of connections that's going to be in between
what is it?
each node. So I mean something like this. We're gonna have a connection here, connection here, connection here, 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 here. Also, one connect to this, to that, to this, to that. You get what I'm saying?
yes, sir.
Oh, that one already there. Right. So that formula is going to tell us the number of lines that we're going to have to draw to connect each system to each other system. So it's going to be like this as well, like that. So hopefully you get an idea as to why it is referred to as the spaghetti system integration. Let's go back to the slide. The spaghetti system integration, because after a while, the problem that we're going to arise is for small systems, it starts up, or the number of connections that we'll need is relatively small, right? Which slide is this? This is slide number 7. Yeah. So for small systems with just a few entities or just a few systems, subsystems, you find that the number of connections that you're going to have to establish between each system is relatively small. Just a while ago, I showed you an example with 2 systems. We just need 1 connection because system A going to talk to system B, and that's it. If you add a third system, system A need to talk to system B need to talk to system C, and system A need to talk to system C. That's 3 different connections. And the number goes up. If we have 10 entities, then we're going to have 45 different connections. And the more the number goes up, the more the number of nodes go up, the number of connection goes up in like a exponential kind of way. So see if you can do the math and tell me if you had 100 nodes, not doing 100. If it was 15 nodes, how many connections would it be? When he said it was 10, it was 45 connections. What if it was 15 nodes? What if we had 15 systems that needed to communicate with each other? How many channels of communication would we need for 15 systems?
105, sir.
105. And that is more than double than what when it was just 10, don't it? And all we did was add 5 more systems. Make sense? Do we see one
Yes,
of
sir.
the drawbacks of choosing a spaghetti integration?
Too much.
Yeah, it's too much. It's way too much, especially if you have a system that requires connections between, I wouldn't even say more than 10, because 10 is a lot. 10 systems, 45 connections, a lot. You get into chaos very quickly. So one of the things that I've come across in my research is that systems or organizations don't usually plan to integrate their system in this way. It kind of just happens. Yeah. Because maybe it's a case where they start off small and they take for granted that they're going to need a more sophisticated system integration than this. So they start off small and they get some easy point-to-point connections. And it's an easy solution, quite easy to implement. But then as the years go by in that system, you add one more, sorry, in that organization, you add another system, you get 3 connections. Then another year pass, you get 10 systems and now you have 45 connections, and all of a sudden chaos ensues. Not so good, right? So just as a way to remember it, you can use the name to your advantage. Spaghetti, a spaghetti integration. It's called spaghetti for a reason. I don't know if this joke would have landed in this generation, but like you guys didn't watch like what's it called? 8 Mile with Eminem. You guys know what Eminem is? You
Yes,
guys
sir.
know
We
the joke
know
about mom
Eminem,
spaghetti?
sir.
You know about Eminem. So you know the joke about mom
Yeah,
spaghetti?
yeah,
Yeah,
the
man.
song, sir. Yes, sir.
Yeah, man. So like, when things start to hit the fan and chaos start to ensue, spaghetti just start fly out of your pockets. I don't know if you can get that joke. That's a really old joke. Never mind. It's all right. But yeah. Um, Another thing that is very difficult is maintenance in a system like this, where if it's a case where one of the systems go down or you need to make a change in a particular system, say you need to make a change to system B, If you need to make a change to system B, now you are going to have to update the connection between B and A, B and C, B and D, and B and E, because all those systems talk to B, or every system talks to every other system. So making a change to one system going to cause you to have to make a change to every other system in the whole process, or the whole entity, or the whole organization. Yeah. One sec. So many government agencies end up with a pattern like this, where the tax system connect directly to the custom system. And then that custom system connect directly to a licensing system. And then that licensing system connect directly to a revenue system. And then as years pass, the connections or the web of connections become nearly impossible to maintain. And replacing any single system becomes a massive project, because so many other systems depend on its data format. So you might find a case where, because the system was built in a spaghetti fashion so many years ago, you might find that updating is something that, like I said, it's going to become a major project, and it might deter a large business from going the route of modernizing their system, which is not very good. Is a reason why a lot of the processes that we go through as, I guess, adults, a lot of the processes in Jamaica are still paper-based, and it's very difficult, very time-consuming, and very tedious. The paper-based filling out form approach is difficult because, if we had our systems computerized, we'd be able to implement more sophisticated systems that just, relay information as soon as they need to be relayed. But yeah, we're not at that point yet. And it's not just Jamaica, it happens all over. I think it happens very often in banks, where you have a lot of bank back-end systems that are dependent on very old computer hardware. And it's because of the tight coupling that they have in their systems that prevent them from wanting to replace it. Because if you replace one thing, you're going to break another thing down the line. And we all know that money is really important. If you mess with anybody's money, you'll never hear the end of it. Right? Do we agree?
Yes, sir.
Yes, sir.
All right. So the spaghetti problem, as I was saying, with the number of connections or nodes that you have in your system, the number of point-to-point connections grows exponentially. And I have a little graph here that can show just how quickly you can expand from 3 systems, is just 3 connections, simple. 5 nodes, 10 systems, manageable, but still a lot. You go from 5 to 8 and it more than double. You go from 8 to 10, you add 2 systems and it, what's 28 times 2? Is that 46? Wait, 56? It don't double yet. But you move from 10 to 15 and it absolutely more than doubles. And the more systems you go, you'll find that the more connections you're going to have, which is the reason for your the chaos. I guess I would already shown you the example that I did a while ago with the 10 connections, so we don't have to go through that activity. But it is something that if you want to prove it to yourself, you can probably go through and, list out a few nodes and see if you can draw the connections in between those nodes and prove to yourself that that formula is correct. You can see the formula, right? This thing is blocking it. I don't know if it's blocking it for you, probably not. But yeah. All right. I need to fix this slide. But I'll fix it after. I can just move this out today. All right. So let's take a look at this next slide, where we look at horizontal integration. Horizontal integration is basically the savior of these integration systems. It is very different from the spaghetti integration system. The purpose of the system, it's to present a mature and scalable solution. And we're going to get into what I mean by scalable in just a moment. But after, hold on, sorry. So taking a look at this diagram, we see where we have, in this case, this guy, 8 systems. I'd call it 9. It's 8 different systems, but I guess depending on how you look at it, you could consider it to be 9. And that ninth system, I would consider the middleware or the enterprise service bus to be another system by itself. And I'll explain why in a second. But yeah, we'll have system A down to D and system E down to H, all connected to a common middleware or a common system we refer to as the middleware. You can call it the middleman as well, but like in terms of software development, we often call it middleware. Like you have software, hardware, and you have middleware, right? So if it, or no, let me not say if it's the case. So the middleware is a software that sits in the middle and handles all of the routing, all of the translation, and all of the message delivery between the systems. So think of it um like an airport example. Instead of every single airport in the world offering flights to every other country in the whole world, what we do instead is every major city, where's my notes? Hold on. Every major city will have a hub, right? Or every airline uses a hub. We don't normally have a flight from Kingston that goes to every single state in the US or every other city in the US. Instead, you might go from Kingston to Miami or Kingston to Atlanta. And depending on where it is you want to go, Atlanta will handle the rest of the flights for you if it is within their scope. And if it is not within their scope, they will link you to a different hub in a different part of the world that will be able to handle the rest of the trip for you. Tell me if I'm making sense. I don't know if this example is relatable, but you can let me know if it's making sense. Yeah. That's why it's a case where, for example, even though Jamaica is right beside Barbados, not right beside, but relatively close, you can't just go from Jamaica to Barbados. You have to go from Jamaica. Where you have to go, actually? I don't even know. I think you have to go Turks and Caicos first. I'm not sure. I'm not sure exactly, but you can't go directly from Jamaica to Barbados, not on a regular airline. You have to go to one city first where there's a hub that offers flights to that location. And you have to, basically just wait it out and basically go through the steps required or set out by that system so that we can achieve the smooth, less hectic, less chaotic system integration. So that would be an example of the middleware. Scaling is important or scaling is a benefit of the system because when I say scaling, I just mean how much the system expands or the amount of work that is required to maintain the system as you add new connections or add new components. The spaghetti system does not scale very well because you add one component or you add one node to your system and the number of connections that you need to implement is extremely high. So it doesn't scale very well because the amount of work you have to put in to get it to implement just one more existing node. But with the horizontal integration, if you want to add one system, you already start off with 8 systems in your integration. You want to add one more. All you have to do is make sure that your additional system will come after HI. System I is able to talk the same language as the middleware, and that is it. Right? Because the middleware, even if it can't talk the same language, as a matter of fact, it might be a case where you don't even need to build system I to be different from how it's different from how it is already implemented. System I can come with whatever kind of data formatting it want. All you need to do as a developer is make sure that the middleware is able to communicate effectively with that system. Because the purpose of the middleware is to handle all different kinds of routing and translation and conversion so that all the other systems can benefit from this data, right? How we feel about horizontal integration. Do my examples make sense? Does the concept make sense?
Yes, sir. I understand it
Yes,
pretty
sir.
well.
Yes, sir.
Ooh. So one of the trade-offs, all of these system integrations have trade-off. So one of the trade-offs of this system is typically I have higher upfront cost and complexity. When I say complexity, I don't mean overtime, I just mean upfront. And that's going to happen because the middleware itself is going to become a critical dependency, meaning If it is a case where your middleware, something happened to your middleware, then you might have problems in the entire system, right? Because as we said, the middleware is going to be in charge of handling all the routing, all the translation, all the converting. If the middleware go down, then your whole system gone. There's a problem. So developers are tasked with they're assigned the task of making the middleware systems as robust as possible. Yeah. So they're going to have to include a whole lot of complexity. And with increased complexity and a lot of effort, going to come a whole lot of money upfront. But once you pay off that money, you're good. Hopefully, as long as somebody doesn't try to sabotage your system and bring it down on purpose. Get what I mean? Does it make sense? We don't particularly like the single point of failure. Doesn't give very much peace of mind. But it works in terms of, if you're able to implement the system well enough, then it works quite well because it scales pretty well. Yeah. One sec. And yeah, a lot of different enterprises or existing modern day system or organizations will implement this kind of system. Because of the benefits that I just talked about a while ago. You want to have robust systems so that if it is a case where you want to be able to add a new system, you don't have to update every other existing system. You just need to update the middleware. Yeah. So yeah, that being the main risk. If the middleware goes down and everything stops, that is the main risk. But in practice, the middleware is designed with redundancy. You have multiple instances. You have failover clusters, you have load balancing, and all these terms are going to be going over. But the cost of building that redundancy is part of why horizontal integration has a higher setup cost, but it's worth it for the scalability and the maintainability that you gain in the system in the long run. Yeah. Tell me if that makes sense.
Yes, sir.
Mm-hmm. All right, let's see. The common data format. This diagram I'm fixing, but I'll fix it later. Yeah, so the common data format. And all right, so we talked about 3 different kinds of system integration a while ago. The 4th one, it's sort of kind of another method of system integration, but it kind of comes in the form of making sure that your systems, even though they're made by different manufacturers, different vendors, made at different times, it is a kind of way of trying to make sure from the beginning that the systems kind of follow a standard in terms of communication. Let me see. So instead of having a middleware that is required to convert information from one system's language to another system's language, it would be good if you could just get more than one system, even though they're made by different people. It would be a really good idea, or really good for you if you could make it so that the systems already talk the same language. Let me see. I'm not sure. Are you guys familiar with XML or JSON? Have you come across those formats
Yes,
or
sir.
protocols? Yeah, you have. Okay, which one was familiar? Both of them or one of them?
No, I really haven't really in depth with them, but I've seen them so far
You've seen
and
them
so
so far.
on.
Okay, get you. All right. So XML, JSON or JSON, and CSV, these are all different formats and standards of laying out information, right? And we get different benefits from each one. Some of them are older than others, but you find that if you have a system, you're building a system, and each one of your systems are in charge of handling different parts of the task that your entire system is supposed to accomplish. If all of these systems already talk the same language, then you're going to find that you're going to have very good communication, very seamless coordination and connections between your systems. I was talking about XML and JSON a while ago. If it is a case where you have different systems, for example, system A speaks XML, and then your system B speaks JSON, and then system C speaks CSV. Because we don't have any standard that all of our systems are following, you're going to need a custom translator for each system pair. So you're going to have a translator for A to B. You're going to need a translator from A to C, a translator from B to C. And in the reverse of that, if you need to have, bidirectional communication. If you have bidirectional communication, that's 6 translators for 3 different systems, which could be a problem. So this solution now, common data format, if everybody agrees on the same common format, meaning, for example, everybody talk JSON, then there's no need for any kind of translation. There's no need for anybody to have to convert any data from one to another because everybody talk the same language, right? So we just have 3 different communication or 3 different channels of communication instead of 6. Or 3 different channels of communication, and no need for any translators, no need for any kind of conversion, right? And something like this, being able to eliminate these channels of communication, or not the channels of communication, being able to allow to eliminate these converters and translators can significantly drive down cost, which is good. Yeah. I have a few different other examples of standards we may take a look at in the future. EDI, Electronic Data Interchange, HL7, Health Level 7, so that's like in healthcare systems. We have SWIFT, that's used in banking. I actually think I've heard a little bit about that while I was working at NCB, but I never actually used it. But the ones that I am very familiar with are REST and JSON, that deals with modern web APIs. Yeah. You guys familiar with web APIs and web development? Did you do courses on that stuff?
Yes, sir.
Yes, sir.
Okay. So yeah. Let's go back from the top. EDI. So that's like the OG data standard from way back in the day. Used in supply chains for decades. When a retailer orders from a supplier, the electronic data interchange standardizes the purchase format of the order, basically. For HL7 or Health Level 7, it's a healthcare standard. And an example would be of when a lab sends results to a doctor's system, the HL7 standard ensures that both sides understand the data. So, it don't matter it doesn't matter which doctor you go to. If it's a case where, suppose the doctor sends you to do some blood work at a medical lab, if they follow the HL7 standard, it should make sure that the information that they send to the doctor or to the medical lab will be understood by both systems. The SWIFT standard is a financial messaging system or protocol. When NCB, for example, send money to a bank in London or Sweden or Nairobi, if all of those, and they should, all the banks follow the SWIFT protocol. The SWIFT protocol being so common that that format allows any one of these banks to be able to send or receive money from any other bank. So it is the reason we are able to send wire transfers internationally. It is not to say that that resource is easy to maintain. So you might find that because we are dealing with things money related, you want to ensure that your money is safe throughout the transaction. So, you pay a little bit more money to ensure the safety of your money. To make money, you have to spend money, things of that nature. But that's not, related to this course. That's just, business on a whole. But yeah, note that the common data format is often combined in horizontal integration, where the middleware speaks the common format and each system just needs one adapter. Yeah. Are we okay? We're good? Any questions?
None so far, sir.
All right. So let me see now. Give me a sec. Right. So yeah, some of the things that it's important for us to take note of in terms of the drawbacks and the benefits of the different systems. We look at things like scalability. Um, we looking at the scalability column for vertical and spaghetti, they don't score very well in terms of scalability. Horizontal is quite good, it's excellent, yeah. And we see that this particular form of system integration is the best reason for organizations to invest in a middleware just because of the scalability. Yeah. Looking at coupling, vertical and spaghetti create one tight coupling. And what I said that meant was systems will depend directly on each other. But the horizontal and the common data format create loose couplings. So systems are independent and they're connected through a neutral layer. The cost trade-offs. Notice that the cheapest options upfront, which are vertical and spaghetti, are the worst for scaling. The more expensive options, like horizontal, they pay off more over time, but you have to pay, more upfront, but they pay off over time. And you can consider this like a classic engineering trade-off. Yeah. Yeah. Okay, one moment. So yeah, most organizations end up with the spaghetti integration by accident, like I said. It's not usually intended. And the move from spaghetti to horizontal is one of the most common and valuable system integration projects. So this will be a message for you guys to remember, very important. And it's a kind of thing that might come up in an exam. And not just exams, but it might come up in real life. So when you leave school and you enter the working world, these type of things tend to come up. Yeah. And you know what? I don't know if it's because there's only two people here, but I did not expect to end this quickly. But it's fine. We can have a discussion about it for a few minutes if you want. Give me a sec. So yeah, I will let you guys think about what we've gone over for a minute. I don't know if there's anything more that we really need to go through. While I allow you guys to ask me any questions if you have any, let me just go through my notes for a second. Yeah, so tonight we defined system integration. And we looked at the four main types of system integration. We looked at vertical, star, or spaghetti. We looked at horizontal and the common data format. And the big takeaway is that the different situations call for different approaches. But in the real world, most large organizations need horizontal integration with a common data format to scale effectively. Yeah. I'm not entirely sure what we're going to be doing. Just when is next class? Is it Friday or Thursday? It's Thursday, right? Don't remember. I'm gonna have to check back.
Friday, sir.
It's Friday? I lie. Okay. That's fine.
Yes, sir.
But yeah, looking at the stuff that we covered just now, these are going to be the building blocks that you need for the rest of the course. Yeah. And yeah, like I said, it's not going to be very much. I think I said it earlier. Part of the reason why we're going to be going through the content so quickly is because, not very many people. And if I ask a question, it only going to take so much time for two or three people to answer. And you guys seem to understand the content so far. Let me see. Oh, let me see. Do I have any housekeeping matters that I need to go through? Let me stop sharing for a second. Any questions, by the way? Oh, we'll have three people on the call. Didn't realize.
Sir, how is the coursework and final grading? What is the percentage of
Right.
grading?
Yeah. That's what I wanted to look at a while ago. Let me see if I can bring it up. I should have
Yeah,
had a
one
slide on it,
question
but
before that, sir. Will the recording for this class be shared?
that's a good question. I imagine that's the reason why they do the recordings. The problem is I don't know how they usually distribute the recordings. That's something I may have to go and find out. During Melissa one thing that I would have noticed is that after the class ends, maybe a few minutes to a few hours later, an email is sent out automatically to all the participants. So if that is the case, that may be how you get the video or the recording. But if not, I can find out and let you know. All right, let me see if I can get that information for you on how the course is split. All right, so we're going to be having coursework on units 1 and 2, that's 10%. We're going to have another coursework. Coursework 2 is a case study, and that's going to be 5%. Coursework 3, that's going to be 20%. That's a group presentation, research and presentation, group presentation. You're going to have a practical assessment, which again is a group presentation, another case study, and a final exam. So what does that take us into? The final exam is 40%. So okay, it's a 60/40 course. That is the answer to your question, right? That's what you had asked? The split?
Can I repeat, sir?
What was your question? You wanted to know how the coursework split against the exam?
Yeah.
Yeah, it's a 60/40. So the exam is 40% and the coursework is 60%. Let me see, that's 10 plus
Okay, sir.
50. Yeah. Yeah, final exam is 3 hours according to this 25 multiple choice and 3 essay questions. Wait, 3? Oh, 5 choose
You know
3.
how many coursework pieces there are?
Yeah, man. Okay, let me go to it again. Coursework pieces. So we'll have five coursework pieces. Um, 2 of which are group work. Yeah. It's going to be, looks like 1 test and 4 assignments. And 2 of those assignments are going to be group presentation. Not group presentation, but group work. One is a presentation, one is a practical assessment. Yeah. Any other
All right, sir.
questions?
Thank you, sir.
Yes, sir.
Any
I'm,
other
I'm, I'm
questions?
asking if the mid semester is included in the 5 coursework.
Well, this just a test, but I'm assuming when them say test is a mid-semester, so
So,
I'll have to get back to you. I'm gonna have to confirm and get back to you. But yeah, that would be the 10%, if I'm not mistaken.
okay, sir.
Mhm. All right. Yeah, I'm going to post the slides that we went through so you can go through it on your own time. And if you have any questions, otherwise you can reach out to me on Canvas. But that's been it. And if there are no other questions, enjoy the rest of your night.
Same to you, sir.
Awesome.
Yeah, same to you, sir.